Hi everyone, welcome to my intro to Spring Security. I hope that you're all doing well. Most of us are spending a lot of time at home these days due to the coronavirus outbreak. I hope that wherever you are safe and healthy, and I hope that you enjoy this tutorial. Let's get to it. In this tutorial, we'll cover the key concepts and architecture of Spring Security. We'll also look at Spring Boot's out-of-the-box auto configuration for Spring Security. In your typical Java web application, the client sends an HTTP request to a web server. This server is typically the Tomcat server, but not always. The web server then forwards the request to servlets for processing before returning a response. In a Spring Web application, the servlet handling all the requests is the dispatcher servlet. A key component in Spring Security is a filter. Filters sit in front of the dispatcher servlet and intercept all the requests. Filters can be chained, each performing some action on the request and response objects. Spring Security makes heavy use of these filters and is basically made up of filters and filter chains, and sometimes even filters and filter chains within filters. Now let's look at the filter interface a little more closely. Any initialization or cleanup code can go into your init and destroy methods. The main method in the filter is the doFilter method. Any action that the filter is supposed to perform basically takes place inside this method. It is executed on every single request that the filter is configured to receive. The filter chain object that is passed into the method as an argument gives it the ability for the filter to call the next filter in the chain and pass on the request to it. The very first filter that Spring Security uses is called the delegating filter proxy. The delegating filter proxy is simply a filter that receives all the requests that the container receives. And all it does, it delegates to another filter called the filter chain proxy. The filter chain proxy manages security filter chains, and this is basically where all your filter chains are stored. When it first receives the request, it iterates through all the filter chains until it finds the one that matches the URL pattern of the request. We generally have one filter chain per application, but there may be more if multiple authentication strategies are desired. Now let's look at this diagram and go through the components that we talked about so far. So when the request comes in, it comes into the container. The very first filter that it encounters is the delegating filter proxy. The delegating filter proxy will then delegate to filter chain proxy, which is where all your filter chains live. The filter chain proxy will iterate through all the chains and it will find the correct one that matches your request and it will pass the request to it. After it goes through the entire filter chain, the request will then get passed on to the dispatcher servlet and eventually to the controller. Now, one specific filter that I want to look at more closely is the authentication filter, which is where the request gets authenticated. When the request first comes into this filter, the filter generates an authentication type object called the authentication request. The authentication request then gets passed on to another object called the authentication manager. The authentication manager delegates to yet another object called the authentication provider, which makes use of a service to fetch the credentials for authenticating the request from your identity store. Now, the identity store may be a database, maybe a server, maybe in the cloud. Wherever it is, the user detail service will fetch the credentials and will compare the credentials stored in the authentication request against those credentials. Once it validates the credentials, if they are valid, it will change this authentication request to what's called an authenticated principal, which is basically the same type of object. They're both authentication objects with a few minor differences. And the authentication request holds the credentials, but after it's authenticated, we remove the credentials, and the authenticated principal no longer has the credentials. And the reason is that we don't want to hang on to the credentials for too long for security purposes. After it's authenticated and it's served its purpose, we get rid of it. So the authenticated principal does not have the credentials anymore. There's also a method on this authentication object called isAuthenticated, and which returns a boolean. When the authentication is in the request stage, it returns false, and when it's in the authenticated principal stage, isAuthenticated returns true. Now, so after the request goes through all these different components, through the authentication manager, the provider, user detail service, fetching the credentials, validating the request, changing it to authenticated principal, now it's ready. It's authenticated. It needs to be stored somewhere. The authentication filter stores this authenticated principal in an object called the security context, which is wrapped in another object called the security context holder. The security context holder is a thread local, which means that it lives and is available. It's available to all the threads running in your application, and it lives for the entirety of the life of your session. So as long as your session is going, this object will exist, and it's available and accessible by all your threads in the application. So what this means is that once you authenticate a request and authenticate the user, you don't have to authenticate again and again for all the subsequent requests and calls. You authenticate once, store this authenticated principal in a thread local object that's available to all the threads, and then for the rest of that session, you can just grab this authenticated principal whenever you want to make sure the user is authenticated, and you don't have to go through this process every single time. So now it's time for a quick demo to see how all these pieces work together. For this demo, I'm just going to create a very simple Spring Boot app. I usually like to create my new Spring Boot projects using the Spring Initializer. You can use this URL start.spring.io, and it will bring you to this very page. All you have to do here is to choose a name, an artifact name. I'm going to name it Spring Security Demo, and then add your dependencies. I'm going to add the security dependency, of course, and I'm also going to add Spring Web, just in case I want to make it into a web application later. And that's it, just a name and your dependencies, and click Generate. This will create a zip file for you, and all you have to do is to unzip it and open it in your IDE. So I'm going to unzip this and go to my IDE and open it. Go to Downloads and find it. Okay, just give it a few seconds to resolve the dependencies. All done. Okay, let's take a quick look at the POM. So the Spring Security dependency that we added is here, so is Web, and let's take a quick peek inside the main folder, and here you can find the main method. So that's there's not much in this project right now. There's just a main method, but it's enough to run the app. So let's start our app. And here you go, it started on port 8080. If you notice here, it's already, let me zoom in a little, it's printed a password for you. This is one of the things that Spring Auto Configuration automatically does for you. As soon as you add the Spring security dependency, it will create a few things automatically out of the box. One of them is a login page and a logout page. And for the login page, it also creates default credentials. The username is user, and the password is always printed in the terminal. So let's take a quick look. Let's go to our browser and go to localhost 8080 and take a look at our app. So here we see we already have a login page, user and password. Okay, so it brings us to this default landing page, and if you just change the URL and add logout, you can also take a quick look at the logout page. Okay, so out of the box you have a login, logout, which was auto-configured for us via Spring Boot's auto-configuration. Now, I want to go back and restart my app in debug mode. And I want to take a look at a few classes that we discussed earlier in the slides. So if the first class I want to look at is the delegating filter proxy. If you remember, delegating filter proxy is the first filter that Spring Security uses to act on the request. So the very first filter that the request will meet is this filter. So I'm going to scroll down and find the do filter method. If you remember when we looked at the filter interface, all filters implement this do filter method, and it's where the main action of the filter takes place. So I'm going to put a debug point here, and then I'm going to try and log in again to see if it indeed hits this filter. So, yep, as we can see, the request came to this filter, and I just want to look at a few things while we're here. So if you open this object, which is the delegating filter proxy, I just want to step down to the line where it populates the delegate. Okay, so now it has set the delegate. If you remember, the delegating filter proxy is just a filter that delegates to another filter called the filter chain proxy. Filter chain proxy is a filter that basically holds all the filter chains in your application. So let's take a quick look here. If we look inside this object, which is the delegating filter proxy, we have a delegate which is of type filter chain proxy. Inside this filter chain proxy, all the filter chains of the application live, and as you can see, we have a list of filter chains here. In our case, there's only one filter chain in this application, and if you open the only filter chain here, you see a list of filters inside it. So a filter chain, again, is usually a list of filters, and Spring Boot's auto configuration has added 15 filters here for us out of the box. So if you expand this list of filters, you can take a look and see what filters it provides for us. There are a couple of authentication filters. There's basic authentication, there's username password authentication. There are a few other interesting classes. For instance, this class, security context persistence filter, is where that security context object and security context holder, which is a wrapper for the security context objects, get created. If you remember, that's the thread local object that's available to all the threads throughout your session, and it holds the authentication after the authentication filters have authenticated the request. So I highly recommend going through these filters, examining them, and understanding what's happening in each of these, especially the authentication filters. Okay, so let's take a quick look at one of the authentication filters. If you remember, again, an authentication filter has a couple of components inside. The authentication filter first generates an authentication request, and it will pass it on to something called an authentication manager. As you can see, we have an authentication manager here, and then this will pass it on to authentication providers. Now, providers, it can be a list depending on how many authentication strategies you have. In this case, out of the box, we only have one provider. The provider will then delegate to a service called user detail service, which will fetch the credentials from your identity store. It will bring it back to the authentication filter, and it will validate the credentials in the request and will create an authenticated principal, which then gets stored in the security context holder. So all the pieces that we saw earlier on the slides You can trace them here, and I highly recommend you taking a closer look at all of these classes and seeing how these pieces get created one by one, especially through the auto configuration process. And actually right now I will show you where you can do that. If you go back to the external libraries folder, and here look for Spring Auto Configuration, so Spring Boot Auto Configure. Inside here there is a folder called MetaInts folder. If you expand that, there's a file there called Spring Factories. If you click on this, Spring Factories is the file that lists all the configuration classes that Spring Auto Configuration will go through. And there are three in particular that are related to security that are of most interest to us. And there are these three. Security Auto, let me just take that away. Security Auto Configuration, User Detail Service Auto Configuration, and Security Filter Auto Configuration. So let's take a quick look at these classes and see how they contribute to creating all these pieces that the authentication flow requires. So let's take a quick look at this first one. If you are familiar with auto configuration at all, you'll know that auto configuration uses a lot of conditional annotations. Based on these conditional annotations, auto configuration will know how to behave. For instance, this first security auto configuration class that we're looking at, you'll see that it is conditional on a class existing, and that class is the default authentication event publisher. So this conditional on class means that if this class exists in my class path, go ahead with this configuration file, otherwise skip it. So this class, this particular class, is part of the Spring Security module, which we added as a dependency. Because we added Spring Security, this class is now on our class path, and therefore this configuration file will be executed. So that's the first step. Now this one is just a little side note for you. Security properties is an object that we store a lot of security configuration properties in it, and this annotation basically turns it into a Spring Bean so you can inject the security properties where you need them. That's just a side note. It's not really related to the security flow that we are looking at right now. So again, to go back here, this class is now on our class path, therefore this configuration class will get executed, meaning any bean definitions in it will be executed, and any imported classes will also be imported. So this import means before you load whatever this class is supposed to be creating, like all the beans that are inside it, make sure you load these configuration classes prior. So it actually goes through these three configuration classes first, and then it comes and creates this bean. Now this bean, again, it has also a conditional annotation on it. It's conditional on missing bean. So it will only create this bean if this bean is missing. So if you haven't customized this bean yourself and defined another bean of this type, if it's missing, it will go ahead and execute this method and will create this bean for you. Now, let's take a look at what other configuration files this security auto configuration is importing. So let's take a look at the first one. So this is, so first of all, the class is conditional on missing bean of this type, meaning only go ahead with this configuration class if a bean of this type does not exist. So that means if you actually choose to customize your own configuration and define a bean of this type, Spring will back off and it will not go ahead with this auto configuration. But if it is missing, it will go ahead and configure using these classes. Now, one important class that I wanted to one important method that I wanted to show you in this class is the configure method that takes an HTTP security type as an argument, which is right here. This is where you define what happens to the request. So here it says authorized request, any request, so that means request of any type with any URL pattern needs to get authenticated, and the authentication types are basic and form, which is like username, password. If you want to add to this or change it in any way, you can write your own class that extends this this class web security configure adapter, and then if you do that, the configuration will back off and it will create your own beans instead of the ones defined in Spring Boot auto configuration. Now let's go back to that very first class that we were looking at, which is security auto configuration. So we just looked at this one. Let's look at the second one and see what's happening here. So this class, the most important piece here is this annotation, enable web security. And if we look inside here, and let's look at the first class that it imports, web security configuration. This is actually where all those security filter chains, the filter chain proxy, and the security filter chains get created. The beans for them the bean definitions for them are in here. So if I think the first one that you can start tracing, this would be a good one to take a look at, security filter chain. So this is where your filter chain proxy gets created. The filter chains will also get created, and then they get added to the security filter chain. This is basically where the creation of those pieces get kicked off. So if you look at this bean definition over here, the Spring security filter chain, and trace all the method calls that are made within the body of this method, you can see where the security filter chain proxy and the security filter chains get created and configured. I highly recommend you trace these calls and see for yourself how these pieces, the beans for these pieces get created and configured. Now if we go back, the second piece that I wanted to look at, so if you remember in that spring.factories file, we looked at three different configuration file. One is security auto configuration. Another one that I wanted to look at is the security filter auto configuration. And let's see what happens in there. So let's take a quick look here. The most important piece that happens here in this configuration file is the creation of the delegating filter proxy. So if you look at this method, this bean definition, delegating security filter chain registration, and trace these calls, you can see where the delegating filter proxy gets created through this delegating filter proxy registration bean. Again, I highly recommend you tracing these calls and seeing for yourself how these beans get created. This is, you can see as you dig deeper into this how all the pieces in our authentication security and authentication flows get created. Just to do a quick recap, when the request comes into the container, before it gets to the dispatcher servlet, it goes through all these security filters. The very first filter that the request meets is this delegating filter proxy. As we saw earlier when we were debugging, the delegating filter proxy delegates to filter chain proxy. The filter chain proxy is where all the filter chains live, and then once the filter chain proxy finds the correct filter chain that matches the URL pattern of the request, it will delegate to that filter chain, and all the filters inside that filter chain will get executed. One of the main pieces that we looked at were the authentication filters. Authentication filters are where you have the request come in with credentials. The authentication filter will delegate to a manager. The authentication manager will delegate to a authentication provider. The authentication provider uses the service to fetch credentials from an identity store. It then validates the credentials in the request, authenticate the request, and save the authenticated principal in an object called the security context holder, which is thread local and available to all the threads in your session. And at the end, we looked at how auto configuration creates all the classes and all the beans that are needed for this flow to work. So when you have some time, create an application that has a dependency on Spring Security, just like we did here, and explore. Try to trace these configuration files and see how all the beans get created. Put a debug point and go through the flow step by step to get a better understanding of it. I hope you learned something new. If you have any questions, please leave it in the comments for me. I would be more than happy to address them in future videos. Stay safe and healthy, and I'll see you next time. Take care.